Hello, 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 hello. Today, I'm going to teach you C++, or at least the little bit of C++ that I am capable of. So, here goes. Let's begin. The first thing in C++ that existerizes is the main function. You're always going to have this. This is just when the code runs, it runs the main function. Yeah. Now this is always going to be int for integer, main, already fucking it up. There you go. It's a function, so it gets the funny brackets. And then return 0. This is the minimal program. It does fuck all. This is how you write a function. Main is just main. That's just its name. This is parameter stuff. This says that it returns an integer or a whole number. I'll explain what int means in a bit. And then this says return 0. Why is this here? Well, when a code runs, when some code runs, your computer doesn't magically know if the code is done or not. This, return 0, basically just tells your PC the code is done running and everything is fine now. Thumbs up. And then your PC goes, return code 0 means everything went well. Program complete. If you return the number 1, it gives you an error. But just to show that this does indeed not do anything, we'll grab ourselves a terminal, and I'm not going to go over how to install the compiler. You can figure that out yourself. You're capable of Googling. But we're going to run this funny command, G++, which is a C++ compiler, then the file, -o, and then the resulting thing, which in this case is just going to be test. Would you look at that? Nothing happened. You know what that means? That means it worked. Next, look, we run the file we just generated. And nothing happened. No errors or anything. Cool, that means everything worked. Yep. So, let's cover some basics, shall we? What even is C++? Well, C++. Here you go. Give you something pretty to look at while I type over here. C++, simply put, is a compiled programming language that derives from C, or it's basically C with extra features. The biggest feature, or one of the big features, being that unlike C, even though you can do it in C at this point as well, in C++ you can do that. The ++ operator exists, and that's why C++ is named what it is. Whoa. Now, I said compiled language a moment ago. What does that mean? Well, I'm glad you didn't ask, because you're getting the answer anyways. The difference between a compiled language and the counterpart, an interpreted language, is compiled languages are generally faster and more efficient. Like, way faster and way more efficient. Stupidly way faster and stupidly way more efficient than an interpreted language can ever be. But why is that? Well, this is how it works. An interpreted language basically takes your code and then reads through it line by line and interprets it. And the thing doing the reading and interpreting it is usually written in C. You're starting to see the first issue, and then it reads it, and then it runs it, and then stuff happens. It's like, yay. This means all you do is have the interpreter on whatever operating system you want, and it'll interpret your code, and it'll just work. Then come compiled languages. In a compiled language, you take your code and then you feed it into a special thing called a compiler, the G++ thing from a moment ago, and the compiler will take the code and turn it directly into what's called a machine language, basically. It turns it into processor instructions. That does mean that it explicitly works only for the operating system it was compiled for. If I compile some code for Windows, it will not run on anything that isn't Windows. Likewise, if I compile something for Linux, it won't run for anything other than Linux. The upside is, just binary is literally what's directly fed into your CPU, and so it goes nice and fast, and you have very nice control. This means that talking about levels, C and C++ are more low-level languages. They are closer to just straight-up binary than something like Python, which is a very high-level language, as in it's very high up, it's far away from the bedrock that holds it all. So that's the big difference. Also, I know I said, oh yeah, here's some stuff so you can look at, but I'm really bad at typing and talking at the same time, so yeah, let's take some notes together. Compiled. Oh, the microphone cable's all over the keyboard. I did not think this through. Oh no. How am I going to do this? How am I going to do this? Okay, I need the keyboard in front of me, not the mic. I'm lifting you up very carefully. Up you go. Move the keyboard in front. Oh, is the cable long enough? Barely. Put you back down. Pull the keyboard in front of me. Good job. You have successfully been lifted up and put back down in roughly the same position. Also means the keyboard is now in front of you instead of behind you. Click clack. Yeah, probably picks it up much louder. So what does compiled actually mean? Can I? Oh, no, don't like that. I could zoom in, but I mean, let's be fair. Half of you watching this are not here for the tutorial. You're here to hear me ramble about coding and do click-clack sounds. Yeah. So, compiled. No, it makes it go new. So then, let's see. We have this lovely emptiness here that does fuck all. It does nothing. Now, if we wanted to do the most basic thing called a hello world, and then I have this thing prepared over here. This is what hello world looks like in C++. Whoa. So now we have the main thing again. That's just the main program, and then we have some fancy stuff like this line here. That wasn't there before. And what's this stuff at the top here? Oh. Well, well, let's go through it then, shall we? This up here is import instructions. So, well, that's what it would be called in others. And when you compile something, that means that you have to have everything properly set up before you start. This has some drawbacks. It makes a lot of things more complicated than in higher level languages, but at the same time, it gives you way more control. And more control means generally you can do stuff better. If we look at this up here, include IO stream. IO stream is what's called a header file. It's basically just going to be plopped in front of here. This is a placeholder, and when we compile, what the compiler is going to do is it's going to take the code from IOStream and just kind of slap it on top here. I'm sure it's more nuanced than that, but that's just what we're going to go with. Simple as that. Next we have using namespace std. Now, std stands for standard. It does not stand for sexually transmitted disease. No, it stands for standard. The reason we do this is, normally if you include something from IOStream, let's just comment this out real quick. As you can see, this is now read it out. Oh no, what happened here? It doesn't see the thing from IOStream anymore. What we would have to do is we would have to type standard : and then it would recognize it. So, yeah. But to avoid having to write that all the time, we can just say, oh yeah, we're already in standard, so just, like, we don't have to write it all the time. By the way, if you include different header files, you might not have to write standard : you'll have to write whatever the specific thing for the file you're including is. Just another thing to keep in mind. So, let's go over this. What is IOStream? Well, IO generally stands for input, output. Oh my god. Yep. And then stream is just stream. It's an input-output stream. Oh, we can do stuff with that. Now you might be asking yourself, well, what's an output stream? Like, how's that going to look? Well, you have the console. We could make the program write something in there. Ooh. Okay, I'm going to speed up just a little bit. I'm going to assume you're not brand new to coding. Because otherwise this video is going to be... Oh, fuck, we're already 13 minutes in. Okay, yeah, I'm going to speed up a touch. I don't want this to be like a 2-hour-long video, because that'll take literal ages to upload. I want... Okay. So, IOStream lets you interact with the console. It lets you take inputs from the console, lets you write to the console. Cout, console, out. Shocker, I know. Cin is console input. Wow. This here is called a string. So string is a piece of text. Text goes in quotation marks. Yeah. Now, generally, string is like a special type in C and C++. Normally you have characters. Characters are... Ooh. Normally put in single quotes. And a character is just a single character. That's why it's called a character. Yep, that's all there is to it. Anyways, these little arrows basically just say, slap it in there. Yup. That's all this is doing. So, this program, very shortly, grabs the thing that lets us interact with the console, makes it so that we have to do less writing to interact with the console, even though ironically in this case it's more writing. Then it defines the main function, which has the return 0, and then inside of this main function says into the console output, like slap in this piece of text. Yup. So now, if we go over here and we go, how did I name this? What the hello world.cpp. Yeah, just compile it to the test. Sure, no error. Good sign already. Look, it wrote the horrid text I wrote into the console. Ain't that just neat? Cool. So, next, let's do some data type learning, shall we? Generally, when you work with stuff, you're gonna have stuff you want to manipulate. Like, you don't just kind of want to always just type out a single like line of text. Like, you want interactivity, you want stuff that you can do. Yeah. So, how do you do that? Simple. It's totally simple. So, to define a variable, you first say what type you want, and then you give it a name. You can either initialize it empty and then fill it later, or you can fill it immediately. Here's an example. Int, standing for integer, aka a whole number. We're going to name this number. Sure. As you can see here, this is now a valid thing. If I wanted to now, I could do cout thing number, and this would work. This would just not do anything. If now now I can go number equals 12, for example, and this will put 12 into number. Number. Why are you? Has no storage class or type specifier. What do you mean? We define it here and we put it in there. I guess you can't. Or is this a case of? Oh man, this shows that I had a whole of 3 days to learn C++, because shocker, I know I can code in C. But I'm unsure if C++ has the same for variable assignment. Time to look it up, but it should be fine. Like, come on. Okay, yeah, it would appear that this is correct. Did I do a typo? No, this is correct. This thing is just complaining for no reason and we're going to ignore it. Yup. Man, sometimes. Oh no, look. Number does not name a type. But it's defined right here as integer. Well, there you go. That's just coding for you. Stuff don't make sense. Anyways, okay, cool. I guess we write the value 12 in here. Normally that would work. I don't know why it's not this time. Wait, hold on. Is it? You've got to be fucking kidding me. Okay. Oh, wait, actually that makes sense. Right. So, the value assignment needs to happen in the part that actually makes stuff happen, aka the main function. Or inside of some other function that can then be called in the main function. Whoa, I'm just stupid. Anyways, so we tell it, hey, this exists now, and then it can do stuff. Now this is what's called a global variable. We define it outside of everything, and so any function can now access this and do stuff with it. But that might be inconvenient, so what we can do is we can move this in here. Whoa, look at that. Now that it's in here, something special will happen. If we try to access this outside of this function, outside of the main function, we'll get an error. because now this only exists in the scope of the main function. That's why it's called, if you ever hear the word scope thrown around, that's what that means. It basically just means this is inside of these brackets, so it only exists inside of these brackets. It doesn't exist outside of the brackets. So what will this do? Oh. Let's see. I will do a quick thingy here. Now you might be wondering, what the fuck are you doing? And the answer is, you can chain these together to basically glue together a bit of text. And like, what's this? What's \n? A \n is just the new line escape character. This is just a placeholder that basically says, make a empty line like we have here by the Hello World. So if we just run this lovely thing, look, it outputted 12. Okay, so integer means whole numbers. Then there's float. Float is floating point numbers, so look, they can have decimal points. Floating points numbers can have some fuckiness going on, so if you want to do like more accurate stuff, I should say, I use double instead, which is just a float but twice as big, but that means it's more accurate, so I can do and yeah. Double just means it's more accurate. We already talked about character. Characters are a single character. Yeah. So that's neat. Yeah. Well, let's see then, shall we? There is something special you can do. That is an array. Now, don't be tricked by those high-level languages you might have learned. Arrays in C and C++ must have their size defined at compilation time. Well, the arrays that you don't open during... It's complicated. The general gist is, whenever you make an array, which you can think of as like just a list of things that you can like look into and move around and stuff, the way C and C++ do it is they reserve a chunk of memory, which means to reserve that chunk of memory, they need to know how big of a chunk. They can't just take whatever size they want. You don't have infinite memory. So you need to tell it exactly how big of a chunk. Because of that, let's say this is a character array, so it's a list of characters, and then I go 3. So this holds exactly 3. Will this work? I am unsure. What do you want? Expression must be a modifiable value. Oh, right, I should probably, in this case, actually do all of the defining in one line. So, there we go. What have we done here then? Well, here we have what's called a character array. In C, this is how you used to do strings. In C++, strings are an actual thing that exist, because it turns out working with more than a single letter at a time is really normal, because they're letters, and letters form text. This is a revelation that is revolutionary to C++, is that strings exist. It's amazing. Like you gotta see this shit. So character strings used to be how you had to do stuff. Look, we printed ABC into the console. Whoa! Even though character is only one, these square brackets here tell it, okay, this is going to be an array called number. It's going to have exactly 3. 3 of what? Because the data type means they have different sizes. 3 characters. And so it can hold exactly 3 characters. If I do less, that's fine. It'll just mean that one of the slots is empty. If I do more, we will get a funny error that says, yeah, it's already marking it as red. Too many initialized values. Just no. You're only allowed to have 3. So this can get very annoying very quickly if you're not careful. Well, there is another thing that is very funky, and that is pointers. Now, generally the way your memory works in your computer is you have blocks of bits that are sitting somewhere. Flashbang. Oh, I hate MS Paint so much, but it is a good tool. Let's see. So let's pretend this is memory on the computer, and then you have, what is this? Oop. We do. Then let's pretend that there is a bunch of like zeros and ones here. There's binary stored here. Whoa. Now, your computer just kind of has your RAM that it can shove these numbers into. That's cool and all, but like, how do you know that there's a number in here? Where do you know that the number is? Well, your computer can keep track of that with something called addresses. Basically, each of these funny things has an address. It'll have some like blah, blah, blah. It looks funky, but basically an address is a thing that points somewhere into your memory and says thing here. Simple as that. So we can actually get pointers. I think it's this symbol. Is it that symbol? It's either this or it's this asterisk. We'll just test it. Yep, there you go. So, ampersand and then a variable will give you the memory address of that variable at runtime. So, wherever my computer decided to place the program, and then wherever the code running decided to place this character array, this is the memory address of it. So if the program was still running, I could go to that exact address in memory, rip out those bytes, chunk it up into 3 bits, like three chunks, and then each of those chunks I could interpret as a character, and I would get A, B, C. Yeah. So this is some of the low-level stuff, is pointers. Now you might be wondering, why the fuck would I need this? And I mean, yeah, pointy. Let's make a thing called pointy. It'll be a character pointer called pointy, and it'll be equal to the address of number. And I think generally you do this. All right, does this work already? I closed the console like an idiot. Oh well, now you get to see me navigate through a funny Linux thingamajig. Mount C users me desktop temp and ASMR. Wow, now we're back where we started. GPP tutorial.cpp -o test. I'm stupid, it's not GPP, it's G++. What I was thinking of was GCC, which is the compiler for C. Would you look at that? We did a thing. /test run. That doesn't seem correct. Oh no, I fucked it up. Whatever will I do? Whatever will I do? Should be this, right? Right. Like that should work. Oh, I'm stupid. This is a character array pointer of size 3? No. How does this work? Maybe I shouldn't do an array as the thing here. Let's just make this nice and simple. This is now a number. This is now also a number. There we go. No more issues. Right. So, the way arrays work, you remember how they just grab like a chunk of the memory? They just like reserve a chunk of the memory and go, yes, this is our 3 thingamajigs. The way your computer knows where that starts is it has a pointer that points here, and it memorizes how long it is, like 3 in our case, and then it memorizes how big one of that data type is, so times whatever the fuck the size of a character is, probably 8 bits, and then it just goes chuk, chuk, and then once it's done that 3 times, it just says, okay, anything past here is not the array anymore. But because of this, how to get pointers for it is slightly different. Man, this is an amazing tutorial. It's... How long has... I've been here for half an hour. Fuck. Well, at least I'm explaining pointers already. So, this will show us pointy. Yay. Let's also do some of this, shall we? At colon space the value colon space. So now if I go compile this and run it at this address, and notice it's a different number from last time, because every time we run this code, your computer, your operating system, is going to throw the program in a different point in your memory, and so the address will be different. But the address changes every time we run the code, but the value remains the same. Ha ha ha. Now there's something called dereferencing, which basically just says, hey, the thing that's like in that location, give it to me. So if I put the funny star over here, funny asterisk pointy, what will happen now is, if I compile this and run it, it'll dereference it, which basically just says it'll go to this memory address, look at what's in that memory address, and then grab the interpreted value, which in this case is, just that. Now, there is some funny stuff you can do with this. Because a pointer is an address in memory. You can, but you really shouldn't, because your computer does not like it. Like, at all. Your computer will scream at you for doing this shit. You can totally move the address. Don't do this. You will get funny errors if you do this. Yup. So, why did we not get an error here? Normally, what can happen is, to make code work while other code is running on your computer, all of those different programs need to share all of the memory your computer has. So what your computer does is, specifically for a program, it tells it, oh yeah, you've got all the memory to yourself, don't you worry. But in reality, it fenced off a nice little area in memory and put it in that pen. And then there's another fenced-in area and another program is running in that one, and then there's another fenced-in area and there's a program running in that one. And just so they don't, like, fuck each other up by accidentally, like, overwriting parts of memory of a different program, whenever your computer detects, hey, something just, like, tried to touch a bit of memory outside of their fenced area, you will get a very funny error that basically says, no, 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 operating system does not like you fucking with other programs, cease. Now, what happened here? Well, the thing that happened here, why we got a funny number here, is if we look at our little diagram here again, let's say we told it this was a number here, it's just an integer, so it's just 1, 2, 3, 4, 5, 6, 7, 8. So it's like this thingy here. It's like, okay, nice and simple. I then said +2. So it took this funny bit, and now I'd need to check whether it moves it 2 bits or 2 of the file that you data type that you chose, but I think it's the data type that you chose. So what this will have done is moved this funny thing either 2 to the right or 16 to the right, one or the other, and then it'll read the whatever 8 numbers are there. Now, this bit over here is not defined by us. There's nothing that we put there. But there's still bits there. I mean, your computer's still running. Your code's still running. So, it basically just means you read a random bit of memory. Not recommended. Again, your computer does not like you doing this. So, don't anyways. But like, no, actually don't do that. Like, this is how you can corrupt files and seriously fuck shit up and make your computer crash, worst case. Normally your operating system screams at you and tells you don't fucking do that, but like, just don't randomly mess around with memory addresses. Anyways, so like, yeah, don't do this. So that's pointers out of the way. So hey, look, we've done pointers. Wow. Can't believe I've managed to explain what pointers are. I mean, honestly, pointers are not too complicated. And just means give me the pointer for this thing. Int star means this is a pointer to an integer. Pointy is just the name of it. Then, well, yeah, this will be the address. And then if I do star thingy, we can get, yeah. Yeah. Now, I'm curious. This is turning less and less into an actual tutorial. Who is messaging me? Who darest message me? Do not disturb. Where the fuck was I? That derailed me something fierce. Well, 40 minutes in. Right. Pointers. Alright, this is a shit tutorial, but I'm 40 minutes in. I don't want to re-record this, so I'm not going to. I'm sorry. like, most likely, if you're listening to this, you know what basic data types are. I don't need to explain what an integer is to you, but I'm going to do it anyways. I'm going to go into the more interesting parts, which is, if I go over here to integer, and then type, what? Yeah, int 32. Actually, let's make it a uint. A uint 8. And then what? T? Is that how you write it? What we have done now is made it so that this can no longer be a negative number. In theory, let me double check that. Ooh, it does not like that. Okay. Was not declared in this scope. Oh, okay, so C++ doesn't have that, but C++ can include it from the C standard, what's it called? Oh, C standard integer lets you yoink C's without the pluses integers. Okay, so that's hilarious. Okay, yeah. So C++ can yoink some stuffs from C, which is neat. Basically, just why reinvent the wheel? C already has it, so just use C's. Anyways, this is a really specific way of telling it. It's an unsigned integer. Signed basically just means it can be positive or negative. Like it has a sign, haha. So uint, unsigned integer, means it is a positive number. Period. 8 means 8 bits. It is a positive integer stored in 8 bits. And then the underscore t here, I have no fucking clue what it means. Oh, and then this code doesn't even work anymore. Amazing. I'm just going to not mess around with this. I shouldn't be experimenting in the tutorial video. I really shouldn't be. But hey, let's do something simple. Tell me a number. Cool, cool. Then the next thing what we'll do is, see this? C in, arrows in the other direction. So, what will this do? So far, this will create number. It's an integer. It assigns it value 2. Then we make a pointer called pointy, which points to that. Then we output, hey, at address, we have value, the value. Then we put tell me a number into the console, and then we run this funny thing. So C out, console output, C in, console input. Well, let's see then. If I run this, then, oh, I need to save the file and then compile it. Yep, that would help. There you go. So, as you can see here, we have at address, the number 2, this bit. Now we're here. It's waiting for me to type something. So, let's put 32. Behold, the memory address remained the same because the program is still running, but the value's changed now. We can take user input. Now, with this user input, we can do something extra cool. We can finally cover conditionals, something we haven't done yet. So, what we will do now is cover... Oh right, I forgot a data type. Bool. It can be true or false. The end. So, a conditional is basically just a thing that says if something is true, then do a thing, and otherwise don't. If number is exactly equal to the number 7, then like scream 7 just into the console. There we go. So again, we have the funny curly brackets, and we have the funny semicolons. By the way, this indentation and stuff is called white space. C completely ignores white space. This entire program could be in a single line of code, and it would work the exact same way, because these brackets and these semicolons at the end of statements make it so that it works anyways. Anyway, so if number is exactly 7, it will scream 7. We can also do if number is bigger or equal to 7, or just bigger than 7. Yeah. We could also do number is bigger than 7 and number is smaller than 14. What this will do is it'll check, is number bigger than 7? And if it is, then it'll also check, is it smaller than 14? And only, so like this will be true, and then this will be true. And then it does and, which means this and that needs to be true. So this whole thing will be true, and then if true, do the thing. And if it's not true, then it just doesn't. Here is an example. Compile, run. Tell me a number. So, what's a number between 7 and 14? 12. Look, it screamed 7 at us. Isn't that just lovely? But what if I put in a number that's just smaller than 7? Actually, let's put in 7. Notice it didn't scream 7. That is because we're checking if something is bigger than 7. If we want to include 7, we have to do bigger and equal, bigger or equal to 7. There you go. There are also other operators, which is the OR operator. This one basically just says this has to be true, or this has to be true. So either or works. Yeah, there's also, is it just exclamation mark? Yeah, whatever. So there are some other ways to do stuff. Anyways, if number bigger equal to 7, then we want to scream 7. And then if something is less than 7, else. Do some more curly brackets. And then we can just make it scream sadness. Cool. So now if I type in 3, it screams sadness. But if I type in 12, it screams 7. Wow. Conditionals. You set a condition, and if the condition happens, do the thing. Else, do the other thing. What if I want to check more things? Like what if I want to scream 7 if it's exactly 7? But like if number is bigger than 7, then like we wanna scream number too big, how dare you. And then otherwise if it's too small, so Yeah, you can keep doing this, and you can just keep making more if statements if you want to be special, and then else is just if all of the ones above it fail, then it'll do the else. Wow. Yeah. Let's test it and show it. Oh look, let's tell it a number. Something smaller than 7 gives us sadness, yep, because it's not equal to 7 and it's not larger than 7. If we do 7, it screams 7, and if we do something larger than 7, like 8, then we get number too big. How dare you? There you go. Simple as that. We could, however, also do something funky. It is called a switch statement. Now, how does a switch statement work? Well, if you have something like this, where number just gets checked again and again and again, you might want to instead use a switch statement. It's basically just a more efficient way of writing this stuff. Switch the expression, which in this case is just number. And now we can write the different cases. Case. Number equals 7. Oh wait, right. Do I just go? This doesn't seem correct. Wasn't there a way to do comparisons in these? I could have sworn there were, but no. Well, okay. Oh, right, that's... yeah, whatever. So, if number is exactly 7, then we can do thing, and then we write break so that it doesn't break things. And then if number is exactly 1, we can do another thing here, and then we write break just to thing. And then if number is neither 7 nor 1, hold on, let me... Seven. Now, you might be wondering, why the fuck do we have break in there? And I will explain that in just a second. Then we have 1. And then down here, finally we have default, which is just going to say sadness again. Actually, no, this time it's just going to say, oh, whoa. Which might as well be sadness. So, why do we have break here? Well, sometimes multiple cases can happen. Break just means after you've done doing the thing for case 7, break, as in exit this switch statement and carry on. If none of the cases happen, then the default case happens. You don't have to include a default case, but it's considered good practice, it's considered goodness. You should do it. It is nice. What the fuck am I saying? As you can see, it is 1 AM. I am caffeinated. So once again, we can do a quick little funny compile. And then we can run the thing, and then I can go 1 and it screams 1, and then I can go 7 and it screams 7, and if I do anything else, it'll print oh whoa. Isn't that just cool? Yup. But what if we want to build the Headpat machine from last time? Let's do that. Let's make the Headpat machine, shall we? Headpat machine.c++. I'm going to just yoink this hello world code. Now what I'm going to show you is the structure of how loops work to the Headpat machine. Enter your desired amount of Headpats. Cool. we will want to save how many headpats the user will want. So we'll create an integer, and we'll call it pats, sure. And then the next thing we're going to do is we're going to go C input, console input, and write that to pats. So now we have how many headpats the person wants. Next, we will make a loop. Loops are basically just a way of repeating the same bit of code again and again and again without having to copy paste it into the code again and again and again. The extra special part being a loop, you might not know how many times you want to repeat something. Like, I can't just copy paste the text headpats you every single time, like just a bajillion times, and then magically know when I need to stop. I'm gonna need to define that at runtime. So, or just using user input. So what we're going to do is we're going to write a for loop in this case. A for loop works as follows. So, first, the iterator variable. This should be an integer. We are going to call it I because that's just like the default. Then, as long as I is less than pats, less than the number of pats that we want, what we will do, also these need to be semicolons because they are full-on statements, then we want to do I plus plus. Oh look, it's the plus plus operator. And then we can do out right into the console. Pat. Yep. Pat space. There we go. So, what does this do? Program runs. We ask them, welcome to the Headpat machine, enter your desired amount. We create a variable that we can keep the number of desired headpats. We wait for the user to input a number of headpats, and we save it. Then we do a loop. The loop has an iterator. It's called I. It starts at 0, and then every round it's going to do the following. It's going to check this condition. I less than pats. Well, 0 is probably less than, I don't know how many pats the user will have asked for. So we do the code. Okay, so we output a pat, and then we increase I by 1. And then it checks again, is 1 less than the amount of pats? And let's face it, you listen to ASMR, you probably want more than a single headpat, don't you? Sneaky little bugger. So 1 is less than the amount of pats you wanted, so it'll print out another pat. Then it'll increase I by 1 again, and it'll check again, is 2 less than the amount of pats? And if it is, it just keeps going until we finally repeated this as many times as you wanted pats, and then we're done. So, to demonstrate, I will compile this file. To demonstrate, I will compile the correct file. Shut up, Windows. There you go. Welcome to the Headpat machine. Enter the amount of desired headpats. How many headpats would you like? Let's pick a thematic number. 62. Look, it's 62 pats. Yup. That's it. We just did something neat. Now I'm going to teach you how to do while loops. While. Condition, do the thing. Well, how does this work? A while loop checks this condition. As long as this condition is true, it'll keep doing the thing. So, while pats is bigger than 0. So what this will do is it'll go in here, it'll check, is pats bigger than 0? Did you request more than no pats? And if you did, then it'll run this code, and then it'll go back, check, is pats bigger than 0? And then it'll do. However, you might have noticed, pats doesn't change anywhere here, so this will just go infinitely. And it will just go infinitely. If you do a while loop like this, always make sure that this condition actually exits at some point. So what we're going to do is, every time we output a pat, we're going to do pats minus minus, which is the counterpart to plus plus. Instead of increasing it by 1, it decreases it by 1. So every time you've gotten a pat, the amount of pats decreases by 1. So this will do the same thing, just a different way around. So if I ask for 5, we will get 5 pats. Very simple, very easy. Again, so we tell it 5, it checks, is 5 bigger than 0? Yep. Print a pat, reduce it by 1, so now it's 4. Is 4 bigger than 0? Yep. Print a pat, reduce it by 1. Is 3 bigger than 0? Yep. Print a pat, reduce it by 1. Is 2 bigger than 0? Yep. Print a pat, reduce it by 1. Is 1 bigger than 0? Yep. Reduce a pat, reduce it by 1. 0. Is 0 bigger than 0? No, it's the same. So we're done here, and then it leaves. Now, what if we want to do something more special? And we wanted the Headpat machine to always pat at least once. Well, what you would do is this funny construct. This is called a do-while loop, which basically just says, do this, then check the condition, and then repeat it. So basically, the thing that changes it is, it does the code once, guaranteed, and then it checks the condition. So this will now always give us 1 headpat, even if we request 0 headpats. Like, let's say I request 0, we still get 1 pat. But if I request 5, we still get 5. So now our headpat machine has a minimum amount of headpats it gives us, which is 1. Ha ha ha. Neat. How long are we? We're an hour in. Holy shit, this is getting ridiculous. Oh boy. Is OBS still running as intended? It sure is. Why did I delete the headpat machine? Okay, there we go. Yeah. So, I think we've covered almost all of the basic constructs. So, we've covered arrays. Oh, I never covered how you actually touch arrays, did I? Oh boy, I'm gonna have to do that, aren't I? Oh, off we go back to the main over here. Whoop. Get rid of all of this. And what I will do now is number is now an integer array that holds 5 numbers. This is fancy and tasty and tasty and fancy. And it will contain 0, 1, 2, 3, 4, which just so happens to be the index values for those values as well. So, this creates a list of 5 numbers, as already discussed, and then it puts in the numbers 0, 1, 2, 3, 4. Now, what if we want to do a thing? Let's see. Tutorial. Oh, yeah, okay. That is not the expected thing. What the fuck is it doing? Oh, no, it is. All right, okay. I'm stupid. So, right. Now, you might notice this is the same as it was before. It's like an address, then it's a 2. What's going on here? Simple. This is the array. Why is that giving us an address? Remember how I said that an address is actually just like a thing that points to a thing, and then the computer memorizes, yes, one integer is this many big and there's 5 of them, and then it just like kind of thinks on its own, like, yeah. And so if I ask it, hey, give me like the 3rd item, it just goes, okay, I will move this 2 times. So we have the 1st item, then we move it once, and then we move it twice. So 1st item, 2nd item, 3rd item, and then it knows where the 3rd item is, which means an array is a pointer. That's why we get an address when we tell it to put it in the console. This is the pointer of the array. Wow. Such magic. There is also the joy of if we really wanted to, we could like move it. I think. Oh. Okay, so if I do this, this should give us 0. Yup. And now if I do plus size of int, then this should give us 1, because we take the memory address and we move it to the right by the size of an integer, which means, well, to this 1 over here. Actually, let's move it to the 2 just to be interesting. So we'll move it 2 to the right. So we're at 0, and then we move it 1, 2 to the right, and yes, an actual example of pointer manipulation the way you're supposed to do it. Uh-oh, I fucked it. It didn't work. Whoops. Is it just this? In C, you have to specify the actual, like, amount of memory you want to move. Oh, okay. So in this, it already knows that it's an integer, and so +2 actually moves it the correct amount. Okay. Okay, I can see. I'll stop messing around with the funny pointers now. So, what is this part? Well, we can access the things in the list with the square brackets. Because this is computer stuff and you're an hour in and still listening, you probably already know, but did you know computers generally start counting from 0? Most languages start counting from 0. Yay! There's some that don't. There's some that start at 1, and people don't really like that because it honestly fucks shit up. Like, it's more intuitive to a normal person, but you're coding, you're not a normal person, face it. You're also a furry on the internet listening to C++ ASMR, rambling and keyboard sounds. And maybe you learn something. I mean, if you're coding along, maybe. I am going relatively fucking fast, so if you've never done C++ before, good fucking luck. Okay, so we can access the thing at the second location. So 0, 1, 2, so this will print out a 2. Wow. This can be whatever the fuck I want, by the way. This could also be this. And so when I say, give me the second thing, it'll go 0, 1, 2, and then it'll give me this. Here's proof. I will compile the program. I will run it. Oh, look, it gave me the number I put there. Shocker, I know. So, but what if I want to change this? Well, simple. I am going to do this real quick. I'm going to copy paste this so we can actually look at the difference between them. So what I can do now is I can go to this, say, hey, at the second location, I would like that to be something really cool instead, like a negative number, and it's a totally random number. Oh my god, we changed it to that number. Whoa. Yeah. Congrats. So now we've done arrays. Let's see, is there anything we're really missing? I guess we're missing basic operators. Which is kind of funny to think about. But hey, I guess we're doing basic operators next. This tutorial is so fucked. I guess you've learned all of this, but technically I haven't taught you how 1 + 1 works. Could you imagine? This tutorial has the shittiest structure ever because I didn't structure it. So this, I'm just gonna close this notes markdown file. Yeah, goodbye, you don't exist anymore. So if I write 1 + 1, can you guess what happens? If your guess was it outputs the number 2, then you were correct. Also, I'm just going to again put some new lines around it, just so it's easier to actually read. What the fuck? Okay. Windows sounds. Look, 2. There we go. If I do 1 - 1, oh, oh, for fuck's sake, I keep mistyping. I'm going too fast. Look, it's 0 now. If I go 2 times 3, it'll give us 6. Wow. If I go 4 modulo 2, we will get 0. No. Will we get 0? We should get, yeah, 0. Yeah, because, yeah, okay. What is this? I called it modulo. What the fuck is modulo? You should learn what modulo is. It's cool. So, in elementary school, when you learned dividing numbers with each other, which, by the way, you do by doing a funny slash, do you remember the whole thing where you divided with remainder instead of, like, not whole numbers? So, like, if something just didn't fully split up, you just had a remainder. Yeah, modulo gives you that remainder. Now, you might be asking, why the fuck would I need the remainder? And the answer is, you need the remainder for so many things in coding. Do not underestimate modulo. Modulo is nice. So yeah, we can do this. I can also do, like, divide by 3. Ooh, that's not a whole number. What will happen? It'll turn it into a whole number. Is what will happen. It just rounds. If I explicitly told it that these were floats or doubles, then it wouldn't round. Then it would, like, output the actual number, but I'm not going to do that. Anyways, so yeah, you've seen what dividing and multiplication and modulo and stuff look like. This is cool and great and great and cool. I can make the computer scream in agony. In fact, I will make the computer now scream in agony. Behold. Isn't it magnificent? So, I think that's enough coding. We have gone an hour and 15 minutes. This video is going to take, like, until tomorrow to upload. I am so sorry. At least it's a really long, like, rambling video. Thanks for sticking around. And I hope you learned something.